Okay. Right. So in continuation to our previous class, we started solving exercise 1.2 on this real numbers. We will go for question number 4 next. Yes. So question number 4, what it says? It says that given that HCF of two numbers, so we are given HCF of 306 and 657. We are given these two numbers, and we are also given that HCF of this 306 and 657 is 9. Okay. What we need to do? We need to find LCM of these two numbers. To find LCM of two numbers, we already know that if two numbers are given, okay, if two numbers are given, then product of HCF and LCM, product of HCF and LCM will be equal to product of the numbers. Product of the numbers. So HCF we are already given. It means HCF into LCM will be equal to product of these two numbers. So 306 into 657. 657. HCF is given to us, that is 9. So 9 into LCM will be 306 into 657. It is my kind request to all my friends that don't go for multiplication immediately. Don't go for multiplication first. First cancel all the like terms, and then only whatever it is left at the last, then only go for cancellation. Before that, do not go for any type of multiplication which will make complex process. Okay, if I will go for multiplication here separately, so we will multiply separately and then again we will put it, again we will go for division. Okay, so at the last everything should be done. Means LCM, we can very well write 306 into 657 divided by 9. And now better cancel it. Like 306 divisible by 3. So 313, 0, 326, then 339. Check whether it is also divisible by 3. So 7, 5, 12, 12 plus 6, 18. 18 is divisible by 3. It means it is also divisible by 3. So let us reduce it to a smaller number. We have already reduced to a smaller number by dividing it by 3. Let us reduce this also by dividing it by 3. Then our multiplication will become easy. That's why I told you, I stopped you that don't go for multiplication. Then 3, 2s are 6, 3 1s are 3, 27 is left, 3 9 27. So this LCM will be giving to us as 102 into 290. Again I told you that when you are going for for multiplication, use some shortcut techniques. The shortcut techniques means, like here 1 not 2 can very well be written as 100 plus 2. We can very well write it as 100 plus 2. And multiplying any number by 100 with 100, it's easy. Just put 2 zeros. Yes or no? Okay. So, if we are writing as 290 into 100 plus 2. 100 plus 2. There is 1 not 2 in it. Then, if I am multiplying these two, I am getting 219. Just 20 I am putting here. Easy. Okay. Now, to multiply 219 into 2, little logic you apply. For small interval of time, you just think that it is 220. For a small interval of time, you just think that it is 220 and not 219. And if you are multiplying 220 into 2, then it is what? So 440. 440. Okay. Now here, 1 less was there. We assumed 1 more. There was actually 1 less. It means what? That 1 into 2, so 2 we have to subtract. It means we need to subtract 2. Here it is plus. Okay. So if you are subtracting, even you are subtracting here, in place of 440, you can write 438. We can write or not? 438 immediately. Then we will add. So 8, 3, 9, 4, 13, 1, 1, 2, 2, 2, 2, 3, 3, 8. So our LCM will become 2, 2, 3, 3, 8. So by utilizing this particular rule, we found LCM. If LCM is given, we can find HCF. Okay? Right. Let us see. Let us find out by taking LCM. Now we found LCM. Let us find out that if we are given LCM, 2 numbers are given, and if we are finding HCF, so same 9 should come. Same 9 should come. Let us see. So in case, suppose, if we are not given HCF, we are given LCM. So 306 into 657, as it is we will be writing, divided by this LCM we will write. So 22, 3, 3, 8. Correct? Okay. Now let us see. So we need to divide. Okay. A long division will be taking place, I know. This particular number is divisible by 2 because at the last 8 is there. It is divisible by 2 very easily. Let us divide it. So 2, 1 ja 2, 1 ja 2, again 1 ja 2, then it will become 13, so 6 ja 12, then 18, 2 9 ja 18. Whether this number is divisible by 2? No. Why? Because last digit is not 0, 2, 4, 6, 8. So it is not divisible by 2. But what about this number? This number is divisible by 2. So we will write 2 1 ja 2, 2 5 ja 10, 2 3 ja 6. Whether this number is divisible by 3? Yes. 5 plus 3, 8, 8 plus 1, 9, 9 is divisible by 3. So this number is divisible by 3. What about this number? So 9 plus 6, 15, 1, 16, 17, 18. 18 is divisible by 3. It means this number is also divisible by 3. Let us divide it by 3. So 3 5 ja 15, 3 1 ja 3. Here 3 3 ja 9, 21, 3 7 ja 21, 3 2 ja 6, 3 3 9. Okay. Here again 5 plus 1 6, divisible by 3. 3 plus 7, 10. 10 plus 2, 12. 12 plus 3, 15. 15 is also divisible by 3. We can divide it by 3. So 3, 1, 3. 3, 2 just 6. 12. 3, 4 just 12. 3, 1 just 3. Here, 3, 1 just 3. 21. 3, 7 just 21. Right? Now 7 plus 1, 8. It is not divisible by 3. 4 plus 1, 5. 5 plus 2, 7. 7 plus 1, 8. Okay, 4 plus 1, 5. 5 plus 2, 7. 7 plus 1, 8. It is also not divisible by. It is also not divisible by 3. Okay. Maybe here 7 plus 5, 12. 12 plus 6, 18. Yes, 18 is divisible by 3. But if this is not divisible by 3, how will we be able to divide it? Yes or no? Okay. So it means some another number we need, some another prime number. Okay. It may be because 1 is here. Right. So with 7, if we are dividing this, but it is not divisible by 7. It is not divisible by 7. This number, whether it will be divisible by 7, so 7, 9, 7, 63, 27, it is not divisible by 7. So it means we cannot divide. So it means, let us go for dividing this particular number by 17. By 17. See where this 1 will be coming at the last in prime number. Either it should be divisible by 1, 3. Then only 3, 7, 21 is coming. Then in second part, either it should be divisible by 7 itself, where 7 into 3, 21, so 1 is coming at the last. Or it should be divisible by 11. It should be divisible by 11. Then further 13, because there also 13 into 7, 91 is coming. So these are the options which we need to apply. Okay, after 13, there will be 17. Okay, so 17 if we are going for, we have to check it. We have to check it. There is no separate rule. Let us find out. Okay, so if I am putting 17 here, dividing at the side here, so 1, 2, 4, 1. Or I will write there. That will be more better. Why to make it complex at one place? This place we can utilize it very well for our work. Okay, 17 and 1, 2, 4, 1. 1, 2, 4, 1. Okay, 1 side will not go. Okay, 10 ja 170 also it will not be going. So where it will be going? 17, 5 ja 85. Okay, 17, 6, 92. 17, 7. Okay, so 7. So 7 into 10, 70. 7, 7, 49. So 9, 190. So 17 into 7 is giving you 190. So 1.9 only it will go for 124. 17 into 8 it will not go because it will be more than 124. Right? So here what we are finding? Difference is 5 and then 1. Seventeen threes are 51. So 51. It means 17 has completely divided it. So this 17 has completely divided as 73. 73. Again 73, 7 plus 3, 10. It is not divisible by 3. Though it is divisible by 3, it is not divisible by 3. Okay? So it means we have to go for, because 73 is a prime number. Itself is a prime number. Then we will divide this 6 by 7 directly. Let us see. Okay. So here There is a change. Now, so 73 we will write, and it is 657. Okay. What we will multiply with this 73, means 3 is there, so that we can get 7 at the last. What we will multiply with 3? In 3 table, where 7 is coming at the last. 3 1 ja 3, 3 2 ja 6, 3 3 ja 9, 3 4 ja 12, 3 5 ja 15, 3 6 ja 18, 3 7 ja 21, 3 8 ja 24, 3 9 ja 27. So 7 is coming at the last. It means 9. Let us check that whether with 9 we are getting this 657 or not. Because 73 into 10, 730. So 730 minus 73. Why I am writing like this, gentlemen? Because 73 I want to multiply with 9. I want to multiply with 9. So I am writing 73 into 10, 730 minus, sorry, it is 1, not 9. So it is 73. 10, 3, 7, here 12 is there, 12, 7, 5, here 6 is there, 657 came. This is one method, another one. 9, 3, 27, 2, 9, 7 are 63, 65. Cancelled completely. It means this 73 has cancelled and we have got 9. So now HCF has become 9. HCF has become 9. It means our LCM is correct. So in this way we can check our answer in the examination. In the examination, nobody will say that at the end of the question paper answers are given. You match your answer there. Just like in book, at the back answers are given for exercise questions. But in examination will not be there. Then how to check whether my answer is correct or not? By this method. So we have got 9. Okay? So it means our process is absolutely correct. Right, let us move to next question. Okay. Question number 5, what it is given. Logical question is there. Check whether 6 to the power n can end with the digit 0 for any natural number n. It is being asked that 6 to the power n, whether it will be ending with digit 0. Okay, whether it will end with the digit 0. So, logic. See, if anywhere in any question, if 0 is there, okay, like 10, any number 10, then you are having 2 into 5. If you are going for 20, then you are having 2 into 2 into 5. If you are going for 30, 2 into 3 into 5. If you are going for 50, so 5 into 2. If you are going for 100, so 2 into 50, then 5 into 5 into 2 again. What you have seen, that wherever 0 is there, there will be compulsorily what will come? 5 has to be there compulsorily. 5 has to be there compulsorily in the prime factor. But what about 6? 6 to the power n, we can write, so this is 2 to the power n into 3 to the power n. So its factor are 2 to the power n and 3 to the power n only. There is no 5. There is no 5 here. It means never 6 to the power n. Whether you are putting here 1, 2, 3, 100, 200, million, 2 million, never it will be ending with 0. Never it will end with 0. Because in order to end with the digit 0, there should be compulsorily 5 should come. The prime factor 5 must come. Okay? Understood? Okay. So 2 have 0 at the end. The factor 5 must be a factor. Or prime number 5 must be a factor. So, as 6 to the power n do not have 5 as a factor, so the number, so it will not end with digit 0. It will not be ending with digit 0 for any natural number n. Any natural number, put n value any natural number, million, 2 million, whatever it is, but it will never end with digit 0. Because 5 is not the factor. Okay? Right. So this was a logical question simply. Not very difficult. Logical. So same way you may be given that whether 4 to the power n, it will end with digit 0 or not. 9 to the power n, like this, it will be given to you. Okay. Question number 6. Let us solve question number 6. Okay, what it is? Explain why 7 into 11 into 13 plus 13. Okay. So it is given one expression 7 into 11 into 13 and plus 13 is given to us. Plus 13 is given to us. And another one 7 into 6 into 5 into 4 into 3 into 2 into 1. Okay. 7 into 6 into 5 into 4 into 3 into 2 into 1 and again plus 5. We need to prove that why these two are composite numbers. Whereas if one glance if you will see, you will find that this is also prime number, 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 here ella prime number, this is also prime number. Okay. Then why? These are not completely prime number, it is a composite number. That is there, explain why it is a composite number. So you can see that here plus is there, not into is there. Correct? It means what? This 5, this 1. So what you can write, if you are taking 13 common, then it will become 13 into, so from here it will, or from here 7 into 11. So 7 into 11 plus 13 into 1, 13, like this we can write. if we are taking 13 common. Okay, then further, what we will be writing? 13, here what it is? 77 plus 1, and then this one will become 13 into 78. 13 into 78. So now 13 into 78, so 78 is a composite number. And when this composite number will be multiplied with the prime number, it will become composite number only. It is a composite number only. Similarly here, if we are writing, so 5 if we can take common, then it will become 7 into 6, this 4 into 3 into 2 into 1 plus 1. Then further, 5 into, if we solve this one, so 7 into 6, 42. 4 into 3, 12. 12 into 2, 24. Plus 1. Okay. 5 into, here we can multiply. So 24 into 2, 48. 4. Then 4, 4, 16, 4, 2, 8, 1, 9. 24 into 4, 96. And 96 plus 4, 100. 1008. Okay, plus 1. 5 into 1009. 1009. A composite number. Its multiplication will give you a composite number. So that's why it is a composite number. Right? So in between that plus is making difference. Okay. Let us solve next question. So next is the last question for this exercise, and then in next class we will solve. We will be going for another factors and all, and exercise 1.3 we will move. Question number 7. What it says? There is a circular path around a sports field. So you are having a sports field, and there is a circular path. We are going for some 400-meter run, so 2 rounds of full circular path. So there is a circular path around a sports field. Sonia takes 18 minutes to drive 1 round of the field. If Sonia starts, so Sonia takes 18 minutes to drive 1 round. Okay. Of the field. While Ravi takes 12 minutes of this thing. Okay, Ravi takes 12 minutes to drive 1 round. Okay. Suppose they both start at the same point. If suppose they have started from the point A, both. Sonia will be taking 18 minutes to come back to A. Ravi will take 12 minutes to come back to A. He is taking less time. He is taking more time. Right or wrong? Okay. Now the question says that suppose they have started from same place at the same time and go in the same direction. Same direction. After how many minutes will they meet again at the starting point? After how many minutes will both of them will be meeting at the same point? So in this case, what we will be doing? We will be going for finding out LCM. Okay, so as in that question, what it is given? Sonia takes 18 minutes to drive 1 round. in this sports field. So Sonia is taking 18 minutes. Ravi is taking 12 minutes to complete the round. It means if Sonia had started from A and she had started in this direction, then making a complete circle, moving towards the circumference of this circle, okay, when she is coming back, total time she is taking is 18 minutes. Similarly, when Ravi starts from A and he moves in that same anti-clockwise direction and reaching to the point A, he takes 12 minutes. Now the question is that if both of them, means Ravi and Sonia, have started from this point A and they kept on moving on this circular path. They kept on moving on this circular path. Then at what time they will be reaching at the meeting, not reaching, at what time they will be meeting at the same point A. Why? Because there is a gap between these two. So Sonia is taking 18 minutes, means she will be taking more time. Ravi will be taking less time to reach to the point A in one round. But one time will come when both of them will meet each other at this point A. That point we need to find out. And if we need to find that particular point, that time, it means we need to utilize that LCM and HCF what we have studied till now. For this question, you can see that the answer we can assume. We can assume what? That once, if Sonia had started from here, she has taken 18 minutes. Ravi has started from here, he will be taking 12 minutes. Then again another round they have to go. It means this time has to be the time when they will be meeting together, that will be more than 18 and 12. That will be more than 18 and 12. So this particular logic, if we are applying here, then we know that in LCM and HCF, LCM used to be more. LCM only will be more than these two numbers. HCF will not be. Okay? So this LCM will be more than these two numbers. It means we need to find LCM of these two numbers. Okay. So LCM of 12 and 18 we need to find out. Right? Again we will go for factorization. So 12 we can write as 2 into, again 2 into 3. Then we can write it as 2 to the power square into 3. Then 18 we can write as 2 into 3 into 3. So what it is? 2 into 3 square. Now what is LCM? How we have defined? We define LCM as product of greatest powers of all prime factors involved. Then in this LCM of 12 and 18, it means which are the power? Here factor 2 is there, here factor 2 is there. If both of them are common, which is greatest? So 2 square is greatest. So 2 square. In this 3 it is there, which is greatest one. So 3 square is the greatest one, gentlemen. So 3 square. Now this will be equal to 4 into 9. and it will be given to us as 36. So LCM of 12 and 18 is giving us as 36. It means Sonia and Ravi will be meeting each other at this point after 36 minutes. Okay, so Sonia and Ravi will meet each other at the same point after 36 minutes. Okay, gentlemen? So in this way, we solved questions related to exercise 1.2, and this exercise 1.2 was basically related with finding out HCF and LCM, whether it is 2 number or whether it is 3 number. Okay, and how that LCM and HCF concept is being applied in real applications, that also we get to know. HCF already we are knowing, because in exercise 1.1 we solved questions related to HCF. Okay, same type of question, statement type of question we solved in this particular exercise 1.2 also, which was related to LCM. Okay, so very nice. I feel that everybody has understood, and we will be meeting very soon with another concept from this particular chapter in next class. By then, bye. Thank you very much.